Hey everyone, and welcome back. Today we'll be having a look at using the Sonoff S31 to enhance the smart home capabilities of your conventional appliances. Specifically, we're going to be looking at how to determine the current operating state of your laundry washing machine and have it send an alert when it's time to move a washed load over to the dryer. Now, I should say, this video was directly inspired by a video I saw on DigiBlur DIY's channel, which does the same thing using the same hardware. DigiBlur puts together a great, easy-to-follow tutorial to achieve all of this using purely Home Assistant and MQTT. It's a great video, and I really hope you check it out. I'll link it in the description below. Since DigiBlur has put together their video leveraging Home Assistant, I thought I'd show you a couple other ways to make it happen. One way using a pure NodeRED flow to act on specific state conditions, and a hybrid flow leveraging NodeRED's Home Assistant nodes to puppeteer HAS, like we do so often on this channel. So, let's get started. The first thing that I've done here is I've gotten my Sonoff S31 and I've flashed it with Tasmota firmware. Now, you don't necessarily need to use a Tasmota enabled device to do this. You can use the stock firmware on most devices, but it's going to be a little more difficult to get them communicating on MQTT and might take a little bit of research and elbow grease. For this tutorial, we're going to be focusing on the S31 with Tasmota flashed. Now, I put out a video yesterday of how to flash Tasmota, and DigiBlur also put out an even better video on how to flash Tasmota onto the S31, so I'll link both those videos in the description below as well. But we can see here that I've got a fresh flash of Tasmota on my S31, and the MQTT configuration is set up like this. So I've got my MQTT host listed here. I've set the client ID to S31 washer. I've set my user and password, and I've also set the topic that I'm going to use. So the topic I'll be using is S31 washer. The full topic will be devices/S31 washer. Other than the custom MQTT configuration, the rest of this S31 is bone stock. It works fine this way. You can go over to the Tasmota wiki on GitHub and look into the power delta commands if you want to maybe increase the reporting resolution of your S31, or you can increase the resolution by changing the reporting time window to something lower than 60. But I found the bone stock S31 with Tasmota is more than good enough to manage my washing machine. Now, once I had that set up, the second thing I did was I ran a wash load to profile what my machine looks like while it's washing clothes in order to better determine which values indicate that it's running and which values might indicate that it's off. So for the most part, my machine in an off state is reading 1 watt. And just for reference, all the monitoring that I'm doing is based on the power value that the S31 is broadcasting. So while my wash machine is off, it's drawing 1 watt of, I guess some people call it phantom power. But what's important to me is that I have a state where I can determine that the wash machine is off. While it's running, we're drawing anywhere between, 28 watts all the way up to 148 watts. So it's pretty obvious and pretty evident when the machine's on. Now, the behavior of my specific washing machine is that once a wash cycle completes, the washing machine will sit in a state where it's powered on, but the motors and drives are turned off. It's just in an on state where the word finished is reading on my LCD display. And during this time, the washing machine is actually drawing 5 watts. So that differs from it being off where it draws 1 watt. In this kind of like post-washing state where it's waiting for me to open the door, it sits and draws 5. And then as soon as a user comes and opens the door to transfer the laundry, the power consumption drops back down to 1 watt. So that actually puts me in a unique position where I'm able to determine where a wash cycle has just finished and it's waiting to be transitioned over. And we can base our alarming around this state. So we're not going to be bothering people unnecessarily if they've already transferred the wash, if they were on it, pretty quickly. We're only going to pester people to transfer the wash when it's in this waiting state, when we know it hasn't been emptied yet. So let's get into the meat and potatoes of it. As far as the Home Assistant side is concerned, the only thing that I've done here is I've created a very simple MQTT sensor in my sensors.yaml, or if yours is in configuration.yaml, that's fine too. So I've set the platform to MQTT, I've named it washing machine, and I've set the state topic to devices washer state. And that's all I've done because we're going to manage the sensor states from the back end in NodeRED. So let's take a look at that now. So here we are in NodeRED, and this area right here is where we're managing the washing machine state. So we actually have this listing directly on the S31 washer sensor topic. And all we're doing here is we're taking all the sensor information that Tasmota puts out. So we're taking voltage, current, power, apparent power, all this different stuff that it puts out as a single JSON push via MQTT. we're converting that into objects from JSON. So I've got this JSON node that's converting between JSON string and object, and it's applying that to the message payload. And we're putting it into a change node. So we're actually extracting the specific value that we want, which is payload.energy.power, and we're setting that just to be the message.payload to simplify things. So once it goes through these three nodes here, by the time it's coming out of this, it's only a numerical value that represents the wattage or the power of the machine. The next node here is the aggregator. Now this is not a node that comes with NodeRED by default. You're going to have to go to your manage palette and download the NodeRED contrib aggregator. So as we have power values coming into the aggregator, what it's doing is it's creating a rolling average, and I have mine set to the last 2 minutes. So every time a point comes in, it'll average the past 2 minutes worth of points before pushing it into the next node, where we're going to try to determine what state the machine is in. What this does for us is it kind of smooths out the jagged edges that we have on our running state. So we have a couple of times here where it spikes down to 5. And as we know, a value of 5 typically would indicate that the machine is in that waiting state where it needs a user to come and unload the completed wash load into the dryer. However, this downward spike has occurred right dead center of the wash cycle. So we don't want to create a false positive here and incorrectly say that the device has gone into the waiting state when clearly it hasn't. So that rolling average is going to smooth out these jags and increase the accuracy of our state determination. So out of the aggregator, we go into a switch node, and this one basically divides up the different power draw values into what state the machine must be in. So we can have a look at that. So we can see here that the top node is, if it's less than 3 watts, we're going to say it's most certainly in its off state. If it's between 4 and 6 watts, it's in its waiting state, and anything higher than 7 watts is in its running state. Now, obviously, you're going to need to profile your own machine. You're going to need to look at the types of values that come out of your machine while it's running. But this is what works for me in my situation. Also, the behavior of your machine, you might not have a waiting state. You might only be able to determine if it's running or not running. It all depends on how the machine's been set up to behave after it finishes a wash cycle. So say done to that. All of these just go into a change node where we're converting the numerical value of the power draw into a English word. We're going to make that off. The string value in here is waiting, and the string value in here is running. And once we have determined that state, we're then going to push it to device's washer state over MQTT, and that is where Home Assistant is listening for the sensor we created. So I've got some nodes here, some injection nodes that can simulate the washing machine changing state. So we're going to see how that's working in Home Assistant just to be sure here. So we'll have a look at that in Home Assistant. So we're going to simulate a wash cycle running, and we'll have a look in Home Assistant, and we can see that it is indeed running. And then we'll simulate the power being shut off, and we'll look in Home Assistant, and yes, it's off. So that MQTT sensor is working really nicely. Now, down below here, we have some logic set up. So what my use case is I would like to receive an alarm when a wash load completes and continue to be pestered until either myself or my wife move the wash load into the dryer. So the approach I want to take with this is I want NodeRED to determine when we enter the waiting state following a running state. So I don't want any false positives to come up if someone goes upstairs and just turns on the machine without running a wash load and then it moves into the waiting state. I want to make sure that we're only alarming on going into the waiting state after the running state completes. And then I want to continue alarming at a set interval just to kind of like keep pestering us to change that washing over. I want those alarms to stop once that's been done. So once the washer door is opened and it enters the off state. So the first example I have here is a pure NodeRED example. So we have this MQTT listen node hooked up to the same MQTT topic that the Home Assistant one is listening on, and that's the one that receives these string values for state. So this runs into a switch node, and depending on the incoming state, whether it is off, waiting, or running, we'll flip it out of one of 3 outputs. So when the machine enters the running state, we simply create a global variable called washer state and set its value to running, and then we pass the message on, but that message goes nowhere. When the machine enters the off state, we do the same. We set the washer state global variable to off, and we return the message, but it goes nowhere. So these are kind of just placeholders for if we want to add any actions later on that are dependent on these states. On the middle node that's attached to the waiting state, we do things a little bit differently. So we can see here the first thing that we're doing is we're creating a variable and setting it to washer state, which will be reflective of whatever value the washer state variable is holding before this node was triggered. And we're setting that into a variable called previous state. And then just like the other nodes, we're updating the washer state variable to be reflective of its new state, which is waiting. So now using a conditional statement, we're going to determine if the last state that the washer was in was running, and that's going to tell us, again, that a wash cycle has just completed. So we're only passing a message on if a wash cycle has just completed. And we can see that here. We're returning message, and we do have it flowing into other nodes. So I can see I've left a debug node here. This was from when I was building the flow. It's not important to the functioning of this flow, so I'm just going to remove it. And now we'll have a look at this part of the flow. So if we've determined that a wash cycle has just completed, we're going to want to send a push bullet message to my phone to alert me to that. So in this node, we create another variable called current state, and we assign it to the current washer state. And then we have a conditional that says if the current state is waiting, then we send a message to alert me that the wash load is complete. And the reason for this conditional will become apparent in just a second, because if you look, we do send a message, but after this node, we flow into a delay node. Now this delay node is set to 30 seconds, but I think more realistically, we're going to only want to pester me every 30 minutes to, get downstairs and handle the wash. So if you remember the conditional that's inside this message, if you remember the conditional that's inside this node, so as long as the value of that global washer state variable is in waiting, it'll continue to loop using this delay, loop through and send a message every 30 minutes. As soon as that state changes, whether it changes to running or changes to off when we've unloaded the washer, then the messages will stop. So this is a pure NodeRED example of how to achieve this. Now we're going to take a look at another way to do this using the Home Assistant nodes for NodeRED. And you can see that the Home Assistant nodes actually simplify this quite a bit. So I would call this a hybrid approach. This isn't a purely automations.yaml approach like we have in DigiBlur's video, which there's nothing wrong with that, of course. But if you do like puppeteering Home Assistant from NodeRED, this is probably the approach that would be easiest to achieve. Here we have a very similar setup. We have a state change node, which is monitoring the washer state, which for all intents and purposes is similar to listening to the topic directly. However, this will only report state changes, so it's kind of nice in that sense. And then we flow into a run state node, which again is just filtering on the string value of the washer state. So here's where it starts to get interesting. Home Assistant actually provides a lot of additional data with its state change nodes that's more than just the payload. And we're actually able to determine the previous washer state without having to go through any of this additional logic or using global variables. So let's have a look quickly at what these messages actually look like. And what we're going to do is we're going to hook that up to that, and we're going to go into the debug node, and we're going to say, instead of just delivering the message payload, deliver the complete message object. We'll say done to that, and we'll deploy it because we're going to simulate a state change. So right now it's in power mode off. We're going to switch it to power mode on, which is again the waiting state. Okay, so we can see the message that Home Assistant gave us has a lot of additional information. It's got the basic payload, which is waiting, which is what we expected, but it's also got this data object, which encapsulates an old state object, which we can actually see that the old state was off, the new state is waiting. And we'll go back to power off now, and we'll verify that again. We can see that the old state is waiting and the new state is off. New state off, old state waiting. And that's really cool because we had to write functions to handle this here and use global variables and yada yada yada, but we can simply just look at this switch node and say if the message.data old state.state was running, then pass it on. If it wasn't, then don't. So we're passing this on. Instead of passing this directly to a notification node, in this case it's a Google say, but it could be an Android push, it could be push bullet, it could be however you want to notify yourself. This is just gonna say something over my Google Home saying the wash load's complete. we're going to go into a trigger node first. And the trigger node is going to take on some of the functionality that we had with this waiting node. The trigger is going to resend this message every 30 seconds. Again, this was just for my example. In real life, it's going to be every 30 minutes. It's basically just sending any message into that Google Say node to get it to deliver its message. So once it gets a message that's come from run state waiting and past the conditional that the previous state was running, indicating again that a wash cycle is completed, it's set up to send to tell the Google Home to send its notification message. Now, it'll keep doing this every 30 minutes. We'll make this minutes because seconds is a little crazy. Every 30 minutes until it's been reset. Now, how do you reset a trigger node? So what I've done is I've used this box right here. It says reset the trigger if message.payload equals off. Okay, so any messages coming from this will never equal off. They're always just going to be the string waiting, because that's what the switch node passes on. It passes on waiting message, right? Out of the center point. But if we have a state change to off, meaning that door has been opened, it'll get picked up by Home Assistant here. It'll get deciphered by the run state switch node, and it will go and reset this trigger. Meaning, if we've triggered this trigger node to send a message every 30 minutes, we can then switch it off or reset it the first time we get an off message. So let's have a look at what that looks like here. So in order for this to work, we have to be in run state running. Okay, and we are in run state running, which means the next time we get a waiting message, it'll actually make it past the switch node and start the trigger. So let's go now send it to run state power on or run state waiting. So you may not have heard it, but my Google Home upstairs did just finish saying that the wash cycle is complete. And we can see that the trigger node, if you look at this little blue dot, we can see the trigger node is waiting 30 minutes to resend that message, and it'll keep doing that every 30 minutes until it's reset. So we will go up to the top again and we'll simulate a power off. We'll pretend that I went upstairs and opened the door to transfer the laundry. And we can see that now that trigger node is no longer triggered. The blue dot is gone. It's not going to resend that message, which is exactly the functionality we're looking for. So this is just two approaches of making this happen. And I wanted to use the washing machine example because it's an appliance most of us have, and DigiBlur DIY did such a good job explaining, the logic behind these types of alerts. So I'm happy to just augment that information and show a couple other sides of the coin on how we can do this. Of course, the same logic can be applied to similar cycling appliances like dishwashers, or it can be applied to something like a stove to see if you've left it on too long, or a refrigerator to see if the door's been left open. There's a lot of possibilities of things that you can do with power monitoring like the S31 provides. And the washing machine is just kind of a great introductory appliance to show some of the capabilities and kind of get your mind working on where it can go. Anyway, thanks for tuning in. I hope this was helpful, and we'll see you again soon. Bye-bye.